So in the last video, we have understood how gradients work and what are gradients. But have you ever thought how Pytorch knows which parameters to update during training? The secret lies in a single word, Autograd. So Autograd is a Pytorch's automatic differentiation engine. It tracks all the operations performed on tensors with requires grad equal to true and builds a computation graph. Now, this graph records how each tensor is related to others. So, when you call dot backward function, Pytorch can compute gradients automatically using the chain rule. Now, there are plenty of video tutorials you'll find on chain rule, but if you want me to make a video tutorial on chain rule, then drop a comment and I'll make sure to create a nice math intuitive video tutorial on what is chain rule and how chain rule works. Now, coming back to Autograd, think of it like this. If you have a function y equals to x squared, Autograd can tell you the slope is 2x without you manually doing all the calculus. Now let's see all this in action. So we'll create a tensor, perform operations, and let Autograd computes the gradient for us. And then next, we'll see how gradients flows through the real models and how dot backward actually triggers backpropagation across multiple layers. So let's get started with that and let's write some Pytorch code and see how Autograd actually works. So I'm going to create the notebook and I'm going to name this Autograd Tutorial. And first thing we have to do is import Torch. As we have Torch imported, the next thing we should do is check the version. And this is 2.9.0 with CUDA support. Now the very first thing we'll do is create a tensor. So I've already created a video tutorial of different tensor functions that we have available in Pytorch. If you haven't checked that out, make sure to watch that video first so that you know how we create tensors and how tensors actually work in Pytorch. So I'm gonna say torch.tensor and I'm simply gonna pass 2.0 and let's have a look at our x. So this is tensor with a scalar value, nothing fancy. Now, let's say I want Pytorch to keep track of the gradients. What I have to do is use this simple variable or argument. So same thing, 2.0, and then I'm going to say requires grad equals to true. And let's see x. And for the sake of video tutorial, let's name this variable something else. So y is my tensor without requires grad and x is my tensor with requires grad. And now we'll see how Pytorch actually remembers and how it calculates the gradient for us. Now let's try to perform some operation on tensor x. So I'm gonna say, let's say x new equals to x times 2 plus 3 times x plus 5. So this is nothing but x squared plus 3x plus 5 operation. And let's run this. And now if we look at x new, we get this. And with this x new, we automatically get this gradient function add backward. Now let's talk about this add backward. This add backward 0 actually means this tensor wasn't just created manually. It's the result of an operation that Pytorch is tracking for backpropagation later on. So in short, Pytorch knows exactly how x new depends on x. So later when we call dot backward, it can automatically apply the chain rule and compute the derivative of this statement. So no calculus needed on our part, it's all automatic by Pytorch. Now if we want Pytorch to calculate gradient of this x new with respect to x, all we have to do is call x new dot backward. Now once that's done, call the grad attribute our tensor, and there you go. You have the tensor 7. Now how Pytorch reached to this 7 is again the chain rule. So x squared plus 3x plus 5, using the chain rule we get 2x plus 3. And if we put x as 2, we get 2 times 2 plus 3, which is 7. Now what happens if we try to do the same operations on the tensor that does not have requires grad as true, which means Pytorch is not keeping track of the gradient for the backpropagation. So let's see what will happen. So I'm going to say y new equals to y times 2, or y square actually, 3 times y plus 5. So pretty much the same operations. Now let's see the value of y new. Everything same, tensor value is 15, but it doesn't have requires grad as true. That's why it doesn't have the gradient function. Now if we want to call the dot backward on this, it will give us error that element 0 of tensor does not requires grad and does not have a gradient function, which is pretty much self-explanatory because we are not asking Pytorch to keep track of all the operations to compute gradients later on. Now let's look at somewhat complex example. So I'm going to create a tensor again. So torch dot tensor, and let's create a scalar only. So 3.0, and let's say requires grad equals to true. This is what our x looks like. So I'm going to create a variable called a, and I'm going to say x times or x squared. Then I'm going to create a variable b as 2 times a. And then I'm going to create a variable c equals to b plus 3. Let's call c dot backward. Or actually, let's have a look at c first. So c's value is 21 and it has a gradient function add backward 0. So let's call c dot backward. That means I want to calculate derivative of c with respect to x. And let's see the value. So x dot grad, and that is 12. So what is happening? Pytorch internally builds dynamic computation graph that is connecting x to a to b, and b to c. When we call dot backward, or when dot backward was called on c, it traverses this graph backward and computes gradient automatically. Now let's look one more example with vector. Right now we were looking at scalar values, but let's create a vector and see how gradients work there. So I'm going to say x equals to torch dot rand n, and 3 comma requires grad equals to true. Let's see our x. So this is what our x looks like, which is a vector. Now let's create a variable called y equals to x times 2, and I want sum. So x times 2, then I can call dot sum. And now let's create derivative. So I'm gonna say y dot backward. That's derivative of y with respect to x. And let's see the grad now. This is what gradient looks like. Now again with chain rule, x times 2 will give the gradient value as 2, and that's why each of the gradient is 2. So that's like saying for every 1 unit increase in x, y will increase by 2. Now let's say once your model is ready and you are doing an inference or prediction on your model, you don't want to calculate gradients then. So there should be a way to disable Autograd so that Pytorch doesn't keep calculating gradients when we are actually doing inferencing, not the training. So in Pytorch, there are two ways to do this. One with using the context manager torch.no-grad, and another one is detach method. So I'm going to show you both. So first thing I'm going to do is show you context manager. So with torch.no-grad, let's calculate z as x times 3. And let's see the z value. So you see there is no requires grad here, or no operation, or no gradient function. Now similarly, you can use detach method as well. And detach method actually creates a new tensor without gradient history. So let's say y equals to x times or x cubed. Let's have a look at y. We get this gradient function power backward. Let's say I want a tensor where Pytorch should not keep the gradient history. I'm going to say z equals to y dot detach. Let's have a look at z. It's same tensor but without gradient history or gradient function. So this is extremely useful when you're doing the inferencing and not the training, because during inferencing you want maximum efficiency from your model, and that's why we use torch.no-grad. And once we actually start training model, you'll see we will be using this function a lot. So with that, we'll wrap up this video. I hope you understand what Autograd is and how Autograd works. Now please make sure to understand what chain rule is, because it's really important to have that visualization and intuition. And if you want me to make a video tutorial on that, please comment and I'll make sure to create a video tutorial explaining how chain rule works and what is chain rule. With that, see you in the next part. Thank you so much for watching.